Hello everyone. In this video we will see the most common built-in functions of Matlab, and we will start with strings. You can convert anything to string with a string function. Let's see how it works. Let's say a is 5.89, and if you want to convert it to string, you can use string function, which is string a. And you know, a character array is not a string. For example, hello. This is not a string, this is a character array. And if you want to convert a character array to string, you can use string function again. And right now, the result is string. And if you remember, if you write length, let me define a string here, as is equal to string a. Right now I have a string, and if you remember, length of a string is 1. Why? Because it's not a character array and it's a scalar. And if you want to learn the length of a string, you need to use set str length function, which s it returned 4. Why? In here 1, 2, 3 and 4. My string's length is 4. And in strings we have an erase function. Let's say I have a string which is hello world again, and if I use erase function s, and for example I want to erase the spaces, then the result will be hello world but without a space. And if you delete L, you cannot see L in my string right now. If I don't give any parameter, if I don't give the second parameter, it will throw an error. So you need to define what you want to delete from that string. Let's give an array, let's say A and L. Right now, erase function deleted EL, but it deleted the EL together, not separately E and L. It removed all ELs which they are together. They not deleted separately, E and L. You can see that I have still some L's. I only deleted E and L. It deleted the L. And let's write something else. S equals to today is a beautiful day. I forgot to write U in here. Okay, doesn't matter right now. And we have a split function to split our strings to a string array. Let's use it. Split my string. and the result is an array, and the result is a splitted version of my string. If you notice that it's splitted by the spaces. If you give another parameter in split function, for example, let's say a, right now it will split my string by the character a. Right now I have thought why, because after the I had an a, then it's splitted, and I'm continuing y space is space, and there was another a because in here I split it in here, and then it will be space and b, then I have another array, I split it again, and t full space d, and then I have another a, and the last one will be y. You can split your string with respect any character or any string or any character array. To convert a number to a string, you can also use num to str function, which is 5.9. If you notice that the result is a character array and not a string, so you need to use string function to convert anything to a string scalar. If it doesn't matter for you, the result is string or a character array, then you can use num to str or something else. And if you want to convert any string to double, you can use double function. For example, let's use it. Let's say 5.9. The result will be 5.9. And let's change it with a single quote. Right now it's changed. Why? This is a character array, and each character has an ASCII code, and the character array is converted to a double array according to their ASCII codes. To prevent this, we can use str2 double function. Right now I can give 5.9. This time my character array will be converted to double directly, not separately. And I have an upper and lower functions. The upper function will make my string uppercase. If you remember my string as was today is beautiful, it will write today is beautiful day, but this time it's uppercase. I want to change my string. Today is a beautiful day. Yes. Right now my string is originally uppercase. If I want to make it lowercase, I need to use lower function and lower s. And as you see, the result is lowercase. And for strings, let's write here another string backslash tab space 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 something here space 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 backslash tab space space space. I have a string with a lot of space, and if you want to get rid of that spaces from the beginning and at the end of your string, you can use str_trim function. Right now, as you can see, it trimmed the whole spaces from my string, but it doesn't trim the tabs because Matlab sees that tabs are not spaces. If you write your string like that, and if you use str_trim function again, right now the spaces from the beginning and the spaces at the end is trimmed, and I have a clear string right now. Okay, these are the string functions. I want to clear my workspace and I want to clear my command window. Right now I have math functions. The most common two math functions are ABS and SQRT. The ABS return the absolute value of your number. For example, if you write here -5, the result will be 5. If you write here 5, the result will be 5 again. But if you create a matrix with rand_n, which produce random variables which is negative and positive, let's say 3, it will create a 3 by 3 matrix. And if I use ABS function for my matrix, now as you can see my matrix will be totally absolute. And let's use the SQRT function. SQRT function will return you square root of your variable. For example, SQRT4 will return 2. And if you use SQRT with a matrix, right now A, it will return a matrix of square roots, your matrix. And right now, if you see, I have a complex numbers. Why? Because in my A matrix, I have negative variables, and the square root of that negative variables, the result will be a complex. To create a complex number, you can use a complex function, or you can directly create with I keyword. For example, let's create a complex function, complex number with, let's say, 5 plus 3i. Right now I used I keyword. As you can see, I have a complex number right now. And let's say if you have 1 2 3 1 2 3 and 4, 5, 6 matrix, and let's create another matrix. Let's say it's rand, and result can be -2, 2 by 3. Right now I have A matrix and B matrix. Right now I can create Z equal to complex B or A and B, and this function will create a matrix of complex numbers, and the real part of that complex numbers will be the first parameter, and the imagination part of my complex number will be the second parameter. If you can see, the first one is 1 plus 0.6277i, which is came from B. And let's create another complex number right here. Let's say 5 minus 3i. To get the real part of that complex number, you can use real function, real x, which is 5. If you use real function with a matrix, with a complex matrix Z, it will return you a matrix which consists all real parts of the complex numbers. As the same way, we can use imagination to get imagination parts, imag function. And for x, the result will be -3, and for z, which is a matrix of complex numbers, the result will be a complex, but this time we have imagination parts. And the norm function will give you the magnitude of a complex number. Let's write norm 3 plus 4i. So the result will be 5. Why? The square of 3 plus the square of 4 and the square root of that sum will be 5. This is the magnitude of complex number and the norm of complex number too. This is our complex numbers. And I want to clear my workspace and also my command window. Right now in Matlab we have lots of matrix generators. We have some special matrix generators too, but we don't cover them in this video. In this video we will cover the most common ones, most useful ones. Let's start with zeros. The zeros will return you a matrix that its values all are 0. Its all values are 0. Let's check it. 3 and 5. 3 by 5. It will return 3 by matrix full of zeros. At the same way, I have another function which is ones. If you use ones with 3, it will return 3 by 3 matrix full of ones. These functions gets the sizes as a parameter. Let's say 3, 4, 2. This time it will create three-dimensional array which full of ones. Right now, as you can see, I have 3 by 4 matrix for the first page and 3 by 4 matrix full of ones for the second page. And we already know we have rand function, and the rand function also receives size as a parameter. If you write a one parameter, it will return a square matrix which is 3 by 3. If you use rand n function, right now it will return the negative values too. It can return negative values too. And if you use rand I function, this time it will return some random integer. If you use, and in here we can write sizes, let's say 3 by 3, it will return random integers between 1 and 3, and the dimensions will be 3 by 3. Let's check it, and let's change the limit in here. Let's make it 9. Now I have 3 by 5 matrix and full of random integers between 1 and 9, as you can see. Okay, let's clear my window again, and I have an I function. I function will return identifier matrix, and which means I matrix origin in math. Okay, let's create I 5. As you see, it returned 5 by 5 matrix and its diagonal vector is full of ones. This is our I matrix. If you use this function with another dimensions, the diagonal will change, because in this situation there is no complete diagonal because it's 5 by 4. Let's clear again. And there's a different type of I function, which is DIAG, diag. The diag function receives a vector as a parameter, receives a diagonal vector as a parameter. For example, let's give 1, 2, 3, 4, 5. Right now it will return 5 by 5 diagonal matrix. The diagonal values is the values of the parameter vector, the diagonal vector. Okay, let's clear again. As of now, we have seen lots of matrix generators, but they were for numbers. Right now, I will create a matrix for logical variables. If you use true function, with a size parameters, right now you will get 5 by 3 logical array, 5 by 3 logical matrix. As you can see, because of that I used true, my all variables are 1. If you use false for some size, you will receive a full of false, full of 0 logical matrix. And there is a complex we have already seen in this course. And we have some special matrix operations in Matlab you can easily do. One of them, you can get the diagonal vector of any matrix. For example, let's say A equal I 5. As you can see, my diagonal vector is full of ones. To get that diagonal vector, you can use direct function. If you give your matrix as a parameter, you will receive a column vector, and which is a diagonal vector of your matrix. And let's create something random, 5 by 5 random matrix. And if you use direct function for that matrix, you will receive that the diagonal vector of that matrix. The first one is 1524, 1067, 0844, 1818, and 5499. And we have a norm function. Let's create a vector which is A equals 3 and 4. If you use norm function for that vector, the result will be 5. And if you divide your vector by norm of your vector, which is norm A, and you will reach a unit vector of your original vector, which is 0.6 and 0.8. Let's clear our window, and we have a determinant function to get a determinant of your matrix. Let's create a matrix which is random 2 by 2 matrix, and to get the determinant of that matrix, you can use a det function, and you will receive the determinant of your matrix. And we have one of the most useful functions, which is the AIG function. Will return the eigenvalues or eigenvectors. Let's create a random matrix which is 5 by 5. To get the eigenvalues of that matrix, you can use a function directly with A, and you will see that you will have 5 eigenvalues in a vector, in a column vector. In this example, the eigenvalues were complex numbers. And if you want to reach the eigenvectors and eigenvalues together, you can use the same function, but this time the setting will be different. The vectors and values, and will be equal egg function again. If you use it, it will return something different. Right now, I have column vectors right now in here and 5 by 5, and they doesn't fit to my window, so it divided it. The columns 1 through 3 is here and columns 4 through 5 is here, and each column in here is one of the eigenvectors. And if you look the eigenvalues matrix, my eigenvalues is the diagonal vector of my Wiles matrix. If you use diag function for the Wiles matrix, the results will be the eigenvalues of my matrix A. This is useful. Okay, let's clear everything and let's clear my window again. And we have some trigonometric functions in Matlab, which they are built-in functions, and we have some static numbers like pi. Pi is already implemented in Matlab, which is 3.1416, and it's continuing. And in trigonometry, we have 2 degrees. One of them is radian and degree, and you can convert the radian to degree with rad to degree function. And if you use here a pi, the result will be 180. And let's use pi over 2. Right now the result will be 90. As the same way, you can convert any degree to radian. Let's use it. Deg to rad. This time I will give 45, and the result will be pi divided by 4. Let's write pi over 4. The result will be same. And we also have some trigonometric functions in Matlab, which they are sine function. If you write here, if you use a sine function, you need to use the radian. You need to use the radians. For example, pi or pi over 2. If you use it, the result will be 1. If you want to use degree, you need to use sine d function, and this time you can write a degree here. For example, 90. The result will be 1 again, because 90 is equal to pi over 2 in radian. And we have also cosine, which is cosine pi will be -1. And we have also tan. Let's write pi, then the result will be too small. Actually, the result should be 0, but in Matlab, as you can see, it's really close to 0, because it's -1.2246 times 10 over minus 16. It's too small. If you round it, pi, the result will be 0. And we have an arctangent and arcsine. Let's use arcsine with a sin function. A sin 1 will be 1.5708, which is pi over 2. And if you want to use degree version of arcsine, you need to use arcsine, a, sine, and d. If you use 1 here again, the result will be 9. And let's see the arctangent 2 for degrees, and the result will be 45. This was the trigonometric functions in Matlab. Let's clear and continue with polynomials. In Matlab, you can use polynomials with arrays, with vectors. If you have a vector, you can use that vector as a polynomial. For example, let's create one. P equals 2, 5, and minus 8. If you want to use that vector as a polynomial, that vector will mean that 2x squared plus 5x minus 8. And if you use p equal to 3 minus 4, 5, and 9, and this time your polynomial will be 3x over 3 minus 4x squared plus 5x and plus 9. And if you want to find the roots of your polynomial, you can use roots function. If you give your row vector in here as a polynomial, you will see your roots. You will see the roots of your polynomials. My polynomial was a third degree polynomial, so I have 3 roots. And let's change something. I want to create a polynomial which is x squared minus 4. That's all. X squared and minus 4. And to do that, I need to write the coefficients correctly. For x squared, my coefficient is 1. And for x, my coefficient will be 0 because I don't have any x. And the constant coefficient will be minus 4. And this polynomial means that x squared minus 4. That's all. Right now, if you use roots function for this polynomial, the result will be 2 and minus 2. It's easy to see that. And if you remember, my polynomial was x squared minus 4. And if I use a poly function, let's say poly, I will give my row vector as a polynomial, and I want to give 5 as x. Right now, Matlab will put 5 as x in that polynomial, and it will return the result to me. Right now, the result is 21. Why? Because my polynomial was x squared minus 4. The x squared for 5 will be 25, and minus 4, the result will be 21. It's really good. And you can reach the derivative of that polynomial. Let's remember our polynomial. Our polynomial is x squared minus 4. And if you want the differentiation for that polynomial, you can use poly_dir function. And right now, I will use my row vector as a polynomial. Oops, I wrote wrong. Right now, the derivative is 2 and 0. The coefficients of the derivative is 2 and 0. Why? Because it was x squared minus 4, and its derivative will be 2x. That's all. And right now I have 2x and 0 constant. As the same way, you can do the integration with polyint function. Let's see what will happen. And right now I have 1/4 row vector. Why? Because my polynomial was second degree, and its integration will be third degree, and you can see that 0.3333x over 3, and I don't have x squared right now, and I have minus 4x. Why? Because I had minus 4 constant, and in the integration you will see that minus 4x. And in Matlab, you can create a polynomial vectors, the coefficient vectors of a polynomial, from the roots. If you have roots, let's say I have roots on -2 and 2, and if you want to get the coefficients of polynomial whose roots are -2 and 2, you need to use poly function. If you have poly function and if you have roots, right now it's r, you will receive a coefficient of your polynomial, which is right now it is same with my polynomial. And if I use the roots again with p, the result will be -2 and 2. And that's all for polynomials. Okay, let's clear our window again, and we have some nice functions for arrays, for vectors, for matrices. let's create a vector with integer vector, with an integer vector which is random 1 by 6. Oops. For integer I need to give here 1 by 6 and the limit will be 9. Yes, right now I have a random integer vector. To check any variable exists in my vector or in my matrix, I have a function which named is member. Let's check 5 in A exists or not. Matlab says that 5 exists in A. 5 is a member of A. Let's check it. 4, 9, 8, 5. Yes, I have a 5. If I write in here 15, it will return 0. Why? Because I don't have a 15 in my vector A. And you can also use a vector to search, to check exists in another vector or another matrix. For example, I will use the same vector again to search, and this time I will not give a scalar, I will give a row vector. I will give a vector here. I will say 1, 2, 3, 4, 5, 6, 7, 8, 9. Instead of to write this, I can write a colon operator which is 1 to 9, and I don't need that brackets too. Right now it will return a logical array. Why? Because I am looking for an array exist or not exist. In my array 1 is not doesn't exist, 2 doesn't exist, 3 doesn't exist, 4, 5, 6 exist, and 7 doesn't exist, 8 and 9 exist. And you can also use a matrix to search, to look for. For example, right now I have a random integer matrix and I want to check for each number from 1 to 9. As you can see, I have everything right now, and I have 1 in here, 2, 3, 4, 5, 6, 7, 8 and 9. It's good. And let's create a vector in here which is random 1 by 4. 1 by 4 is enough. And if you want to find the maximum value of that vector, you can use max function, max v. It will return the maximum value of your vector. Right now I have 0.5785, which is the biggest value of my vector. And to find the minimum one, you can use the min function, and I used that function for my vector v, and as you can see the minimum was 0.2373. And if you use that max and min functions for a matrix, let's use it. Right now we have a matrix here, and let's clear the window and let's remember our matrix and let's use max A. Right now, as you can see, we have a row vector. Why? Because if you use max function for a matrix, it will return the max values for each column vectors. And in A, I have 6 columns. So the result is 1 by 6 vector. And for the first column, the maximum value is 8. And the second column, the maximum value is 9. And the third column, 9, 7, 5, and 9. As the same way, I can also use min function, and you can see that I have minimum 2 in the first, 2 in the second, 2 in the third, and 3 in the fourth column, 2 in the fifth column, and at the last column I have 1 as a minimum. And let's clear our window again, and let's remember our row vector, and let's try to sort it. To sort a vector, you can use a sort function. And if you give your vector as a parameter, and the result will be sorted in an increasing order. First one is the minimum one, and then the elements are increasing. If you want to sort by decreasing, you can use the sort function again, but this time you need to add another parameter here, which is descend. It will be descending order. Right now, as you can see, the values are decreasing as the indices increase. And for matrix, let's clear here and let's remember our matrix. If you use sort A, right now you will see that your matrix will be sorted, but it is sorted in columns. If you notice that the rows are not sorted, but the columns are sorted, as you can see, and the ascending order. If you want to change the order, you can also use descend here. Right now they are sorted in columns, but this time descending order. And if you don't want to sort your matrix by columns and you want to sort your matrix in rows, you can use a dimension parameter too in the same sort function. And let's clear and let's use the same function sort, and let's give our matrix as a parameter, and this time you need to define your dimension. Right now I will give dimension 2 for the rows. Right now you will see that the rows are sorted with ascending order. If you want to make descending, you can add descend parameter 2, and then you will see that your array will be descending order in rows. By default, the dimension is 1, which means rows, as you can see. Let's clear. To To check an array is sorted or not, we have a function is sorted. Let's create a random integer matrix, but this time a little bit smaller. Random integer, let's say the values will be from 1 to 9 and my dimensions will be 2 and 3. I have 2 by 3 matrix, and if I use is sorted for that matrix, the result will be 0. Why? Because it's not sorted. If I use is sorted, let's say with descending order, it's 0 again. Okay, let's remember our vector, and I want to sort my vector in a ascending order. Right now I have a sorted vector, and if I use is sorted function for that vector, the result will be 1. If I sort my vector with a descending order, and if I check is sorted the result will be 0. Why? Because it's check the vector is sorted in ascending order or not. To check it is descending order or not, you need to use a descend parameter in here too. For the matrix is sorted method, I will use my matrix in here, and I want to use the first diameter, and I want to use descending order. If you give, the result will be 0. Why? Because this function doesn't work like a sort function. Let's remember our matrix. Right now, if you want to find your matrix is sorted or not, you need to use a row vector or a column vector. Let's use the first row vector, which is not with brackets, we need to use parentheses, and 1 and all columns. Let's check it. It's false. Why? Because it's not sorted. But if you use in here descending order, the result will be 1. Why? Because the first row is sorted in descending. Let's clear our window, and we have some set functions. The sets in math. They are union, intersect, difference in sets, and unique. Let's create let's create a vector which is rand e9 1 by 7 will be enough right now. And if I use my unique function for my vector v, this function will return all unique variables in my v. As you can see, the size is decreased. Why? Because I have repeating variables, which is 9, which is 4, and in my unique function returned that each element once. And let's look at union. I want to create another vector which named x. Okay, and if I use union function with x and v, my result will be 1, 2, 3, 4, 7, 8, 9. In my vector v, I don't have a 2 and 3, but in x I have 2 and 3, and the union of x and v I have 7 numbers. Let's use the intersection. Intersect function x and v, the result will be 1, 4, 7, 8. These are the common variables between v and x, which is the intersection set of x and v. And let's use a set diff function for the difference in sets. Set diff x and v. This time it will return the difference of x than v. It will return the values in x but not in v. Right? A few seconds ago I have said that in v I don't have 2 and 3, and these are the result. I can use same function, but this time I will give v and x, and this time it will give the difference v than x. Now 9 exists in v but not exist in x. Okay, this is the end of this video, and see you in the next video. Bye.